Well, another Monday is here. I hope you guys enjoyed that little scope ignition scope test I put out there on Sunday. I had put that thing together. It was actually a part of this presentation, but it was going to make this presentation too long, and so to keep this presentation short and manageable, I went ahead and did that. Put it out as a separate thing. Well, a lot of people claim to be first patent the idea of a spark plug. Robert Bosch is this guy right here. You've heard the Bosch spark plug. Albert Champion, a couple of familiar names, this guy here. There was even a patent submitted by Kellum Lee Guinness of the Guinness brewing family. They wanted to take credit for having come up with the idea for a spark plug, which was kind of funny, really. But one way or another, we got spark plugs now, and we got them to deal with. All right. Albert lost the Champion Ignition Company he founded in Flint, Michigan to investor drama, and shortly after he was named president of AC Spark Plug, which was formed with backing from Buick Motor Company. You know, Buick was actually named for David Buick, who came from Germany with the ability, he knew how to marry porcelain to cast iron to make bathtubs. And some people might joke that the older Buicks look like upside down bathtubs because of that, but I don't know anything about that. But in 1901, this engineering a magneto system with this, sounded like a German guy, and he was German too, based on what was the electric arc ignition. See this little distributor and these little magnets going over here, when you whirl that thing, it would create ignition, and they had a little rotor in there that would sort the spark out and send it to the cylinders that were firing at the time, which is what distributors do. When I was a boy growing up, these funny looking little telephone things, which were very similar to this ignition system, by the way, there was a crank, and it had a little ring gear and pinion that would spin the inside of those magnets there really fast, and there was a couple of wires that were sticking out the other end of that thing. And if you could get some unsuspecting yo-yo to hold onto those wires, and the smokehouses around here, a lot of them had these old telephones in them, and you instantly, and there were also those old record players, you know, the old 78 RPM record players that were so popular for a while, with these records you could throw down and they'd break. Those smokehouses had those sitting in them. It was just amazing what kind of antiques you could find when I was a boy growing up around here. Anyway, if you could take those, get somebody to hold on to the two wires coming out of this thing here and turn that crank, it would just fire them up. I don't know what kind of voltage it made, but it was like ignition voltage. And that was basically a telephone. And you would do that to ring the ringer on the other end. You know, the bell would ring in response to that cranking that you did. But people would actually take these out into boats, and they would drop the wires in the water, and they would turn the crank, and fish would come floating up. And that's, you know, one of the ways they would go fish. And I'm not kidding about this. This is the way it was. All right. So now this is do not remember, this is basically a very similar, if not the same one. I may have bunched it together for the purposes of making that thing. I don't remember, but this is a really good, perfect pattern that you get to see. And you got to have this light in here that's going to jump the spark plug gap. That's part of the deal. It's going to burn for this amount of time, because this is voltage over time, and this grid that you see behind it is called a graticule. But anyhow, so basically whenever you you can set the width of your time or the height of your voltage if you're setting up a scope. And this particular one here, incidentally, you can tap into the primary ignition side of an ignition coil and get exactly the same pattern that will give you exactly the same information as this. As far as that, I mean, it's so close that there's, you know, a lot of the newest instructors are telling you really don't need to measure secondary ignition waveforms, because primary ignition waveforms will give you pretty much the same information. Although I kind of like the secondary ignition waveform myself, and everybody that went through that test yesterday knows what this stuff is. Last of the hydrocarbons is burned off with the upkick, and then you get this leftover energy. The gasoline molecules provide a current path that goes away as molecules. So this is when the burn starts. See, it takes this much to jump the gap, and then it burns for this amount of time. This is measured in milliseconds. You notice it's like a 1 millisecond deal there. or the pop of an ignition spark is actually thunder on a tiny scale. You might notice when it thunders, you can count to 6, and if it's you get to 6 before the thunder gets to you, the lightning strike was a mile away. Well, that's kind of like a jet breaking a sound barrier. I used to hear that all the time in the 1960s down here in South Alabama. Whenever a jet would break the sound barrier, you'd never even see the jet, but the sound barrier shout boom on a clear blue day would rattle the windows on the house. Well, whenever that lightning punches a hole in the atmosphere and then the lightning bolt goes away, all that air rushes in and slaps against itself, which is kind of like when a jet goes fast enough to split the air and make a vacuum behind it. It comes in behind it and it goes boom, you know. All right. So you got to make lightning by having this coil. You got a metal core in that coil. Anytime you put a soft iron core and you wrap wire around it, it increases the strength of the magnetic field. That's important. All right, it's a step-up transformer. You know, vaguely similar. The one out on your power pole is a step-down transformer, but it does kind of the same job, only it's going in the other direction. Step-up transformer has been the heart of the gasoline ignition system for decades, and the principle is fairly simple. Whenever you put power and ground here, this heavy winding saturates with magnetism, and that magnetism saturates this fairly fine winding, which is a lot more wraps than the other one. So this 12 volts, whenever you interrupt the power going to this, it's going to collapse across these windings, and a spark's going to come out of there, and it's basically carried. It fires at exactly the right time to go to the center of the distributor cap if you've got distributor ignition, and the rotor sorts out the spark and sends it to where it's supposed to go. One time the president of the college brought an 8-in Ford tractor up there for us to work on. And I said, well, we'll put some plugs and wires and, you know, points and stuff on this thing. So we jerked all the plugs and wires out of the darn thing. And it was a flathead Ford 8-in. And we put points in there. And I got the points all set up, and I said, golly, I'm not sure I know the firing order on this thing. And that was before the internet was such a big thing. And so I pulled, with all the spark plugs out of it, which we'd already pulled it out anyway because we were replacing them, I stuck my fingers in the spark plug holes and had one of the students spin the tractor over, and when I felt the compression puffs, I figured out what the firing order was and got it put back together that way. I had to think outside the box on that one because I didn't have any books that would tell me what it was, and I didn't know when to call anybody, you know. A lot of times if you call somebody, they say, well, let's bring it over here, we'll take care of it, you know. They want you to turn the job over to them. Magnetism induces voltage in copper. Now this copper that's in this coil and the copper that's in motors is not just straight copper wire, it's copper wire with a coating on it, so that when you wrap it around and around and around, there's no continuity. The electrodes, the electrons have to follow the wire. They can't jump from one coil to the other. That's really important. And so you wrap it around that coil, and it's saturated with this magnetic field. I already talked about that. There's your points. There's your condenser. See? All right. This is what it looks like in a schematic. All right, you got 12 volts here, but the 12 volts is not going to be on distributor ignition vehicles. They are going to start. You're going to get its full 12 volts when you're first spinning it on start, but it'll go through a ballast resistor or resistor wires, what they did on Ford, and this voltage after the engine's running drops back to about 8 or 9 volts. And so it basically, if you keep that at 12 volts, it winds up burning up the points and all. This condenser right here, what it did, whenever you open the points, they're prone to be a little spark right here. That condenser would keep that spark from happening so bad, and it would protect the points. But as soon as the points closed, the stored energy in here would zoom back in here and charge this coil up really fast. That's why if you had a bad condenser on one that had distributor ignition, it didn't run good if it had a bad condenser. Of course, everybody knows when you lay a condenser on an engine block and you let it jump to that wire, it stores all that energy. I think I talked about that in a recent video. And my brother was there with his 65 Ford Galaxy convertible one time at the Ford dealership, and I let that happen. Bap, 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 bap. And then the service writer named Tony, who was a funny guy, I worked with him for several years, and I threw that condenser to him and said, here, Tony, catch this. And so when he put his hand up there, it made a pop that sounded like a rifle shot, and he thought he had lost his hand. But then he wanted to know how I did that, and he learned how to charge it up and went all over the shop trying to get somebody to take that condenser or catch it, and everybody but him was too smart for that because you got 25 mechanics in there. They'd all seen this before. But the collapse of the magnetic field, see, the core is not shown here, but they show you the coil, the way it's wrapped and all. Secondary winding is going to be your real fine coil, the primary is going to be that one there. And so there I was playing with an ignition coil. Here's the other thing. One time, you can fire a coil. If you know how to fire a coil and you got something that'll fire a coil, you can build a little box, with a switch and a condenser in it that you can use to fire a coil, if you hook it up. But, some of your old textbooks used to tell you how to do that. But I was working one time on an old go-kart back in the 90s. And it was a go-kart with an old Briggs & Stratton engine on it. Still had points, before Briggs & Stratton went electronic ignition. And I took that thing and that coil off of that old lawnmower, all that old go-kart engine. And my wife was driving a 93 Ford Tempo at the time that was nearly brand new. And I unhooked the coil and I got some jumper wires and hooked the lawnmower coil up, the ground on the E-core and the little wire going in, hooked it up to her ignition system on her Tempo, and hooked the plug wire, her coil wire, to that coil, and it started that Tempo. So when I went to buy some points at the turf and timber place over there, they says, how do you know you don't need a coil? I said, well, I started my wife's car with it. And they got this slack-jawed look and said, how in the world did you do that? A coil is a coil. That's just all there is to it. When you hook up a coil, now some of the coils that have extra circuitry in them, like on some of your coil-on plug stuff, it's slightly different, But as far as that, all right. Now let me back up there. Winding one is known as the primary winding, and this is your points. And there's your condenser. There's your points right there. And so these right here, you might notice your points in your condenser. It's difficult to see it, but there is a little spring that's going around and hooks up right there with that condenser wire. And this is a Delco, 6-cylinder Delco distributor. But there were some distributors that had two sets of points that would extend coil saturation time. You'd see those on some of your Chrysler hot rods and all that kind of thing. The distributor on these old systems rotates at camshaft speed, which is half of crankshaft speed, and the breaker points on older ignition systems open once each cycle. 6 cylinders have 6 bumps, 8 cylinders have 8 bumps. If you didn't put grease on that cam, it would wear that down and then get where your points weren't open at all. I don't know how many times I saw that when I was working on vehicle with points. But one time I went to a local parts house. It was being operated by a guy that I went to high school with. I was working on a 68 Volkswagen Bug, and I didn't want to drive to the town 30 miles down the road where I usually bought my points, because nobody in the town I live near here had Bosch points, because I like Bosch points for a Volkswagen. So I went in there and I said, I need a set of points for, the guy's name was Steve. I need a set of points for a 68 Volkswagen Bug. And he looked in his book and he threw a set of them World Part points on the counter with a plastic rubbing block, they were sorry. And he says, $3.11. And I got to remember this is back in the 80s now. And I said, good grief. I said, Steve, you're getting rich off these darn things. And he bowed up and he said, I don't make more than 15% off nothing I sell. And I said, well, if that's the case, you're buying them from the wrong place, because I can go down to Bapguillon in the town down the road and buy them for 65 cents a set and get Bosch points that are better than these. And he got all flustered. He says, well, he's messing up the parts business for everybody. He's selling them for what I pay for them. He just told me he didn't make more than 15%. That's a huge 15%. Right? All right. So points are gone. They disappeared. Good thing they did. Distributor stayed. Points disappeared. You got this little reluctor here. And that little reluctor will spin past here and it makes a little wave. And that little wave triggers that module to use this power transistor to operate the, let me see if they've got this drawn. Yeah, see, that's coming out of there. So this control module doesn't feed power to the coil. That's not right. They drew this wrong. I actually got that from somewhere. That's not even drawn right. Because this right here is going to come through a resistor typically. I'll show you that again in a minute. Ignition switch. See, you see how the ignition switch, they got it showing right here? They got the ignition switch going to the, well, go to here, I guess. And the negative side of the coil is coming from here. That's a confusing schematic, but you get the point. That reluctor on the Chrysler products was really, had sharp little points on the reluctor. And they had a little pickup coil, they had a little sharp contact on that. The Fords had fat reluctor teeth, and they had a fat on the pickup coil in the distributor that they went past. They had a fat. One time, I got the idea that I was going to take a Chrysler ignition module and fire it with a Ford electronic ignition distributor. Put it on my 74 F-150. Some of you guys might have read a little long saga that I wrote about that truck. Okay, so I put that distributor in there. I mean, I wired it. I knew how the ignition module was wired up, and I'll show you that in a minute on here. And so I went ahead and wired it up, and I could start that thing and run it with a Ford distributor and a Chrysler ignition module, but the only caveat was the fatness of those teeth changed the equation a little. I had to retard the timing to get the vehicle to start. After it started, it was kind of like starting a Model T, you know. I retarded the timing, get it to start, I bring it back up, it would run good. And I drove it some with that, but it was too much trouble. You know, you don't have to retard the timing every time you start the car. And so that kind of went bust. Now, I probably could have altered the teeth or figured out a way to put a Chrysler reluctor and pickup coil there. It would have been okay, but that was too much trouble. I was just experimenting on my own vehicle anyway. All right, HEI came out in '74. These really were bad to burn through the rotor on the V8s and be a no-start. Just about anybody that's been around a while has seen that happen. All right, so there's your little module right here. Now, one of the things I learned from Ellen Smith at General Motors School in 1981 was that you can unplug your pickup coil right here. Have your key switched on, have it so you can check to see if you got fire that's going to come out of your coil. And these two terminals right here, if you have the key on and it's ready to check for a spark, you can lick your hand, lay it on a positive battery terminal, lick your other hand, and tap this, and it will go pap, 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 pap. It won't fire the coil. Because all it needs is 1/10 of an amp coming through your body from the battery. See what I'm saying? You can try that if you've got an old GM around. You can also take a soldering iron. And you can take a soldering iron and hold it up close to that pickup coil and pull the trigger on that soldering iron, and that AC wave that's saturating that thing will go bzzz and make the coil buzz. That's the way you can check that. All right, now Forged Duraspark, look at this very carefully. The orange and the purple go to that pickup coil. The ground comes from here and goes to the module. It uses that ground to fire the coil. All right, this is hot in start, this is hot in run. Okay, so this one's hot in run to the coil, and this is the switch to the green one goes there. That is a very simple and easy to understand ignition system if you're somebody that's got the capacity to understand it. Some of you might remember the 80 model F-150 I took over there. They had a bad module in the parts store, and they tried to give me a hard time because they sold me a couple of crappy parts, and then I had to go get one at a different parts store that would work right. But if you have one of these that are popping and snorting and running bad, and you turn it just a little past the run position to the start position, so you're delivering power to that white one instead of the red one, and it runs good, you know that module's bad. Sometimes these like to leak their epoxy out. It runs down the fender too, you know, the potting on the back side of it. But you can see those fat reluctor teeth on that Ford. Right? All right, now this is the Chrysler. The way this Chrysler is done, if you're going to check a Chrysler module to see if the module is capable of firing the coil, get it where you can check the spark, unplug this, and those two wires right there that are coming from the module, you can touch those together, and it will go pop, 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 pop every time you touch them together, the way it's set up. Now, I've never seen that work on a Ford, but I've seen it work on Chryslers, and that's how I used to check them. With that in mind, imagine what you might be able to do if you got it set up right, and you got an insulated set of points where both sides of it are insulated, and you can have that little set of points just triggering these two wires. Believe it or not, that's how vaguely similar to how some of the Asian people, the Asian distributors, they had electronic ignitions with an igniter, but they would have a little set of points in the distributor for a trigger, and you almost never needed to replace those points. That's the way those things were set up. But anyway, that's a simple thing. You can actually save this image right here, and you'll know how to wire up an old Chrysler ignition module. You can buy those at the parts store. That transistor is what does the job of triggering the coil. You might notice you got a 0.5 ohm resistor and a 5 ohm resistor there. You know, this one here goes to there, and this one here goes to here. It's a dual ballast resistor. If that thing dies, your whole ignition system goes away. GM HEI with fuel injection had a bunch of extra stuff here. You know, you had your 5-volt bypass above 400 RPM and reference low. And whenever you set the timing on those, you had to unplug this little connector. It was a brown wire with a black stripe. when you unplug that connector, you throw a code in it that you have to clear out when you're done on the old, 2-digit ones where you jumper and then flash the codes and all. But anyway, that's the way that module was wired up on the inside. And then of course this is a poor drawing of the pickup coil. Now the General Motors, the old HEI, whenever the vacuum advanced, it had two different advances. It had a centrifugal advance that would move the inside of the pickup assembly, and the vacuum advance would move the outside of the pickup assembly. And you want some advance as you're going up in speed, because with that, whenever the advance goes up, whenever you pick up speed, you need more advance. If you're loaded, you need less advance because it'll ping if you don't. And that's how the manifold vacuum works really well, because when you got a heavy load, your vacuum's low and it retards the timing a little bit just automatically. It worked pretty good on that. But now that one there was totally controlled. The timing was controlled by the computer as long as you had that connector plugged in. And that connector had to be plugged in if you wanted to run worth a crap. On the older Chevrolet, some of them would be on the firewall, some of them would be under there by the glove box, depending on what your model you're looking at. They'll call that as timing connector. Hall effect replaced the reluctor. This Hall effect I had heard was invented by a dentist, some guy named Hall. And he basically, I don't know what he used, I don't know what a dentist would use this for. But the long and short of it is that little chopper plate goes between there. It causes a little square wave to be generated. And when that square wave is generated, that triggers the module. If you have this taken apart and you've got this naked in there and everything's powered up, you can take a hacksaw blade and go between there with a hacksaw blade in between those. That's a magnet, and it's also a little Hall effect unit that's, you block that magnetism where it can't get to the Hall effect unit, it switches, off and on like that. And there's you a little bit of a schematic of it right there. Now Ford's TFI had a Hall effect. There were very, very few, some of the Escorts had a pickup coil with a TFI module. That was very, very rare. It was in the early 80s. But most all of them had this, and they had, up until they started getting cam sensors with sequential electronic fuel injection in the tempos, one of the vanes would be a little narrower. That was your signature pip that told a computer where number 1 was, which that's all it needed on that one. And it needed this. It had no crank sensor. It just had that pip sensor inside there. And that also, profile ignition pickup signal went to the computer to tell it how often to fire the injectors and all that. Now you got your distributor cap where we're at. Now on these Fords, if the distributor rotor burns through, it will cause them to stumble when you give it the gas, and when you cap off some of your air going into the intake, when you boom, 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 it revs up normally. When you let all the air go in there, if you have a situation where one falls on its face, unless you're blocking off some of the air and it's a Ford, or any other kind of vehicle, it can be a Ford or some of these Asian vehicles, you look and see if the rotor's burned through, because if the rotor's burned through, it will do that, because the spark finds an easier place to go. Alright, so there's your optical distributor, like on Asian makes. They got an emitter and a detector, and it's little whirls in between there. Those little slits in there, the little bitty ones for the crankshaft, there's 360 of them. They got to be cut with a laser. They're the tiniest little things, and then these right here would be the, you got a slided wheel there. And on the Toyotas and the Hondas, if you pull the distributor cap off of a Toyota or a Honda that's got that distributor, that coil in there, like if you've got a no start, what I like to do is take my Tesla and hook it to the to the negative battery terminal, and then I go to the trigger side of the coil and I spin it over. I'm looking for a pulse. If I get a pulse, because you can tell when it's pulsing because it's pulsing that coil. If it's pulsing but it's not firing the coil, that's a bad coil. I don't know how many times I troubleshot one of those. On some of them Hondas though, you got to be really, really, really careful when you're putting it back in. That little thing that goes in here on the distributor cap, it's real fragile. You can crack that thing, and it may run for a week before it dies on you again. And that just sort of, that'll beat you up. You have a comeback on one of those like that. All right, so Toyotas and Hondas, you put them in there, and you'll see one like this every now and then. And you can actually just replace the coil. Some of those Hondas, you can actually get all the parts to rebuild the distributor if you want to go to the trouble to do that. 4-liter Jeep and crank and cam sensors. So right here, it's a 50% duty cycle on that. 4 marks on that. That's what it looks like on the scope. I've shown you this before. This is how you adjust it. You want to adjust this distributor so that this is halfway between 2 sets of those. And that's while it's running.
and you'll have some really, and as you notice, this is set on 20 milliseconds.
I did this with an old PDA scope that I was dearly in love with, and that thing finally died. You could not get it fixed nowhere.
Anyway, coil pack ignition works like motorcycle ignition. It's called waste spark because it fires both companion spark plugs at the same time, and one of them is always on the exhaust stroke. They got a crank sensor and a cam sensor like any other system. The time is not adjustable unless you find a way to move the crank sensor. You really don't want that. And that's kind of how it's wired up. You know, people will talk about because it's a full loop like that, if you take this one loose, that one won't fire. But that's nonsense. That one will still fire even if you unplug this one. They used to tell us it wouldn't, but it will.
Now, I will tell you this, on some of your Hyundais and Kias, it seems like it wouldn't matter if you hooked the companion cylinders up backwards. But on some of those, if you hook them up backwards, you'll run into problems because it actually knows which one is number one. Some of the European vehicles, Volvos or something, I can't remember what kind they are, send about 80 volts down to a spark plug, and they notice a deflection in that when it fires, and that's how it determines where number one is rather than using the cam sensor.
Pretty interesting on those. One coil on the Toyota V6, it's got a going down into the head to the plug, kind of like a coil on plug, and coming off the other side of it, you got a plug wire going to the companion on the other side.
The companion cylinder is the one that's up, the two cylinders are up at the same time, are companions. One's always on exhaust, one's always on compression. It's just the way that is.
Okay, coil near plug, you got 8 coils. That's your, but you might notice on this one here, you've got all of these, you got 1, 2, 3, 4 wires. You got low reference, ignition voltage 1, ignition control signal, and ground on that one there. And basically the ignition control takes right here on C is where it gets its signal to fire that. Now, you got a fuse feeding that, you know, that's not too hard. Most everybody's seen those.
You know, it's always a good idea to replace all them plug wires if you can, but I mean, I don't know, I mean, we've changed the plug and just put the same plug wires back on it, you know.
It's a good idea to put these metal things back on here too, though. GM Vortec coil plug has got these funky coils right here. These things die too, they're not perfect, you know. You'll have the 5-cylinder and the 6-cylinder Trailblazers and stuff like that. They have these. Cop coils are set up in this way right here. They got this, this is a fancy little rig right here. You got a primary coil there and secondary coil laying in there sideways. And you notice it's what drives that down through there. It's a pretty cool idea that they came up with. You might want to look up on my YouTube channel where I got a replacement cop coil for a Toyota from a parts store, and it was taking 99,000 volts to fire it. I was using my little GTC 505 to measure it. That is a really instructive video, and it blindsided me on a Friday morning, and I knew I needed to let everybody know what was going on there. If I hadn't had that GTC 505, I would not have known that one of those coils was taking 99,000 volts to fire. The new one I got from the parts store was the one that had to be replaced with a different one. All right, it's types of plugs. You got a conventional plug, a supplementary plug, and a surface discharge plug. And a little bit of clearance between the insulator and the gap reduces carbon accumulation. You can read this as you go. Surface discharge plug may be required in high compression applications or with high energy ignition, and it just jumps right across there. Eliminates interference with electrode tip, and so on and so forth. Federal Mogul has got this Corona ignition system. It uses high energy electrical frequency to produce repeatable controlled ionization. It creates multiple streams of ions to ignite the fuel mixture throughout the combustion chamber. Common mistakes: lack of proper thread cleaning. Delco's spec was 15 foot-pounds. It was on the box for years, right? All right, so spark plugs like this will burn out if you have an intake valve leaking. You'll put a set of plugs in there because they look like this, and within a couple of days they'll be just like that. You got a valve problem if you run into that because it's letting air in there like a torch. All right, so if you got these right here are supposed to prevent flashover like that, but on coil, distributorless ignition units, I would see this, and you'll see tracks down the side of that plug. When you see that, you better put wires and plugs or you're going to have a comeback. All right, you're going to see heavy ash deposits and overuse for fuel additives. This right here, I don't call that overuse of fuel additives. What I call that is valve stem seals. That's what you're typically looking at when you've got a situation like that. All right, so in the presence of overly rich conditions, going to give you some soot there. Not a big deal there. These coils right here cannot take a dead short.
these can. So you're going to limit the amount of amperage on the E-cores. That's all for today. See you later.